Welcome to Hexagon Tutorials Dart series. Let's understand mixins in Dart and how they help in reusing code efficiently without relying on traditional inheritance. A mixin is a way to reuse code in multiple classes without using inheritance. Instead of creating deep inheritance trees, Dart allows classes to mix in additional functionality using the with keyword. This makes the code more modular and flexible. Why use mixins? Avoids complex inheritance. Instead of making long chains of parent and child classes, mixins allow us to add specific behaviors to multiple classes easily. Promotes code reusability. The same mixin can be used in different classes without writing duplicate code. More flexibility. A class can use multiple mixins, allowing us to combine functionalities as needed. How to use mixins? Use the mixin keyword to define a mixin. Apply the mixin to a class using the with keyword. Mixins cannot be instantiated on their own. They are only meant to provide additional methods and properties to other classes. By using mixins, we can keep our code clean, maintainable, and reusable. They're a powerful feature in Dart that helps in writing efficient and scalable programs. Let's write the code to understand the mixin better. Let's understand mixins in Dart with this example. We have two mixins, flyable and singable, each providing a specific behavior. The flyable mixin has a fly method that prints flying high in the sky. The singable mixin has a sing method that prints singing a beautiful song. Then we have a bird class that uses both flyable and singable mixins with the with keyword. This means the bird class inherits the fly method from flyable and the sing method from singable without needing traditional inheritance. Inside the main function, we create an object of bird. The bird first calls its own display method, which prints I am a bird. Then it calls fly from the flyable mixin and sing from the singable mixin, demonstrating how mixins add functionalities to a class. Mixins provide a flexible way to add reusable behaviors to multiple classes without deep inheritance, making the code more modular and maintainable. Mixins and inheritance both provide code reuse but serve different purposes. So the first difference is keyword. Mixins use mixin and are applied with keyword. Inheritance extends to inherit from a base class. The second difference is code reuse. Mixins add extra functionality without modifying the class hierarchy. Inheritance allows a class to inherit properties and methods from a single parent. The third difference is multiple sources. Mixins allow a class to inherit behaviors from multiple mixins. Inheritance follows a single inheritance model, meaning a class can only extend one parent. The fourth difference is use case. Mixins are used when multiple classes need shared behavior without being related. Inheritance is used when a class has an easy relationship with another class. Alright, let's break down this code step by step. Here, we have three mixins: flyable, invisible, and strong. Each of these mixins defines a specific ability that can be added to a class. Flyable provides a method called fly, which prints flying like a superhero when called. Invisible provides a method called turn invisible, which prints now you see me, now you don't. This simulates a superhero turning invisible. Strong provides a method called lift heavy, which prints lifting a car with one hand, representing super strength. Now, we have a class called superhero, which uses all three mixins. The with keyword is used to add multiple mixins, meaning that the superhero class now has all the abilities provided by flyable, invisible, and strong. Inside the superhero class, we also have a name property, which is initialized using a constructor. So, by using mixins, we can add multiple abilities to the superhero class without the limitations of single inheritance. This makes our code more flexible and reusable. Let's understand how the on keyword works in Mixins. First, we have a class vehicle. It has a method move that prints moving on the road. This represents a basic vehicle's movement. Next, we define a mixin called electric. But instead of a normal mixin, we use the on vehicle keyword. This means the electric mixin can only be used by a class that extends vehicle. Inside this mixin, we have a method charge battery that prints charging battery. This represents the functionality of an electric vehicle. Now, we create a class electric car that extends vehicle and also mixes in electric. Because the on keyword restricts the mixin, the class must extend vehicle before it can use electric. In the main function, we create an instance of electric car called Tesla. When we call Tesla.move, it prints moving on the road. From the vehicle class, when we call Tesla.chargeBattery, it prints charging battery. From the electric mixin, the on keyword helps keep the code structured and prevents mixins from being used with unrelated classes. This ensures that only vehicles can have electric functionalities. It improves code safety and organization. Alright, let's talk about the static keyword in Dart. Now, whenever we use the static keyword, we're basically saying, hey Dart, this variable or method doesn't belong to just one object. It belongs to the class itself. That means, static members are shared across all the objects of that class. No matter how many objects you create, there's only one copy of the static variable or method. Let's understand this better. Imagine you have a class called student, and you want to keep track of how many students have been created. If you use a static variable for that, every time a new object is made, that one shared variable gets updated. Not one per student, just one for the whole class. Now talking about static methods, you don't need to create an object to use them. You can simply call them using the class name itself. Super handy for utility methods like calculations or conversions. So in simple terms, think of static as something that's class level. It exists once for the whole class, not once per object. Super useful, super efficient, especially when you want to share data or functionality across all instances. Let's break down this code and understand how the static keyword is working here. We have a class called circle, and inside it, we've defined a static variable called pi. Now, look at the main function. We are printing the value of pi using circle.pi directly with the class name. And that's possible only because pi is marked as static. If we didn't use the static keyword, Dart wouldn't allow us to access pi using circle.pi in the main method. We'd need to create an object just to get the value of pi, which doesn't make sense because pi is a universal constant. It doesn't change from one object to another. That's why we use static. It makes pi a class level property. It belongs to the class itself, not to any specific object. Then, we create a circle object with radius 5 and call the area method. Inside this method, we use the static pi to calculate the area. So overall, the static keyword helps us define values of functions that are shared across all objects and can be accessed without creating an object. Super useful for constants like pi. Let's now take a look at how static methods work in Dart with this example. We've created a class called calculator, and inside it we have two methods: add to numbers, multiply to numbers. But notice, both of these methods are marked with the static keyword. Now what does that mean? Well, by making these methods static, we're saying that they belong to the class itself, not to any specific object of the class. So when we go to the main function, look at how we're calling these methods. We use calculator.add 5, 3 and calculator.multiply 4, 6 directly with a class name without creating a calculator object. That's the power of static methods. They're perfect for utility functions or operations that don't depend on any instance variables. They just take some input and return a result. Now imagine if add and multiply weren't static. Then we'd have to create an object of calculator just to add to numbers. That's unnecessary and inefficient. So to summarize, static methods let you call functions directly from the class without creating objects. They make the code cleaner, faster, and are especially useful in cases like this: utility classes, helper methods, and constants. So, when should we actually use the static keyword in Dart? Let's break it down. Use static variables when you need a value that's shared across all instances of a class. Think about values like pi in a circle class. No matter how many circles you create, the value of pi remains the same. Or maybe you want to track how many objects have been created. A static counter variable would help you do that because it exists only once and updates globally for the class. This way, you avoid duplicating data in every object and make your program more efficient and organized. Now coming to static methods. Use them when the method doesn't need to access instance variables. In other words, when it doesn't depend on the object's unique data. Let's say you have a utility class for math operations like add, multiply, or something like string formatting or unit conversion. You don't need an object for those. Just call the method directly using the class name. This keeps the code clean and avoids unnecessary object creation. So, in summary, if it's a shared value or a utility function, go static. It makes your code more efficient, readable, and easy to manage. Let's understand a real-world example of static variable and static method in Dart. Here, we have a class called user. Inside it, we've declared a static variable user count. This keeps track of how many users have been created. And since it's static, it's shared by all objects. Each time a new user is created, the constructor increases the static count by 1. Then, we have a static method called showUserCount, which prints the total number of users created so far. Since it's static, we can call it directly using the class name. No need to create an object. In main, we create two users, Rohit and Dhoni. They both display their names, and finally, we call user.showUserCount to print the total user count. This is a perfect example of how static variables and methods can be used for shared class-level logic like keeping count or providing utility behavior. Let's see some important point related to static keyword. As you can see here, the warning comes. Next is only static members can be used inside static methods. Why we use const keyword? Saves memory as the value is stored once. Ensures the value doesn't change. Alright, let's do a quick recap of what we've learned about the static keyword in Dart. First, when we declare something as static, it means that the variable or method belongs to the class itself rather than to any individual object. So, you don't need to create an object of the class to access it. Second, static variables are shared across all instances of a class. That means, if one object updates the static variable, the updated value will be seen by all other instances as well. It's like having one common variable for the entire class. Third, static methods can be called without creating an object. You can simply use the class name followed by the method name. These methods are useful when the logic doesn't depend on any instance data. Fourth, we use static when we want to create constants, utility functions, or shared data. For example, mathematical constants like pi, helper methods like converting units, or tracking things like the number of users created. And lastly, keep in mind that static methods cannot access instance variables directly because they're not tied to any particular object. They only work with other static members of the class. So in short, static is perfect for situations where you need something that belongs to the class as a whole rather than to specific objects. Thanks for watching the video. So do like, share, comment, and subscribe to our channel.